So on to problem number 14 of the MIT Integration B qualifying exam 2017. The definite integral from x equals to 0 to x equals to pi over 2 of the square root of sine x plus 1. Now this is one of those problems where you may be quick to want to substitute for things, but it just requires knowledge of the phase difference between sine and cosine, and from there you can simplify the square root sign. So let's see how we may be able to solve it. So from 0 to pi over 2 of the square root of sine x plus 1. You may be tempted to want to take this to a half angle formalism, but you see it's still very hard to remove the 1. So my intuition tells me that, let me just say, let x be equal to u plus pi over 2, such that sine x will be equal to sine of u plus pi over 2, which is equals to sine u cosine pi over 2 plus sine pi over 2 cosine u. Cosine pi over 2 tends 0, and so sine pi over 2 is 1, so this is the same as cosine u. But from here we see that dx is the same as du, because dx du is 1, and so the limits don't really, the variables here don't really change. However, looking at the limits, moving from x to u, when x is 0, u 0 minus pi, so this is going to be pi over 2, negative pi over 2. When x is pi over 2, pi over 2 minus pi over 2u is going to be 0. So our problem becomes negative pi over 2 at the lower limit in the u domain to 0, square root of cosine u plus 1, and that is in the u space. And let's continue. One thing I may want to do is first of all maybe express it in the half angle formalism. So we have 2 cosine u squared, cosine squared u over 2 minus 1, that is the same as cosine u, plus 1, and we see this and that cancel, so we are left with square root of 2, and the square root of cosine squared becomes cosine u over 2. So we've removed the square root sign, and now things are easy for us. We could also say let u be equal to negative y, or vice versa, so that dy du is equals to negative 1, and therefore dy is equals to negative du. And that allows us to, 1, remove the negative sign, and cosine of negative y is going to be equal to cosine of y. So we have root 2. The limits now change in terms of sign, cosine y, and then negative dy. So this becomes negative, and that negative now allows us to change, to flip the limits. So which becomes now root 2, 0 pi over 2 cosine y over 2 dy. Okay, so this becomes 2 times twice sine y over 2, 0 pi over 2. Okay, so this becomes now root 2 times 2 sine pi over 4 minus sine 0. So sine pi over 4 is the same as 1 over root 2, and then sine 0 is 0, right? So this becomes 2. In other words, our integral from 0 to pi over 2 of the square root of sine of x plus 1 is 2. And that's it. So that's it. Easy problem, but interesting. Until next time, bye-bye.